limit as x goes to infinity of x squared plus x over x cubed plus 2x. So there's a few different ways to approach this. It depends on if you know derivatives yet or not. Probably the most intuitive way, and depending on your comfort level with dealing with infinities, is to just think about which of these terms are really going to dominate this value. So in the numerator, x squared is going to get very large, much larger than x is going to get as x goes to infinity. They're both going to get large, right? As x goes to infinity, x is going to become quite large, but x squared is going to become way larger. So we can actually neglect and ignore the magnitude of x as compared to x squared in the numerator. By the same logic, x cubed is going to get large much, much faster than 2x is going to get large in the denominator. So we can say that the limit as x approaches infinity of this expression is the same as the limit as x approaches infinity of x squared over x cubed. And of course, x squared over x cubed, you can make a cancellation there, and you can say that that's the same as the limit as x approaches infinity of 1 over x. And what's the limit of 1 over x as x goes to infinity? 1 over an infinitely large number is going to be 0. So that's probably what I feel would be the fastest way to do it. If you don't really see that, or you don't like thinking about, what do these things become as x gets large, another technique is to divide every term in the numerator and the denominator by x raised to the highest power that you see. So in this case, the highest power that you see is x cubed. So you could rearrange this algebraically as x squared over x cubed plus x over x cubed, all divided by x cubed over x cubed plus 2x over x cubed. And then go through and make your simplifications. You have x squared over x cubed is 1 over x. X over x cubed is 1 over x squared. And then in the denominator, x cubed over x cubed is just 1. And 2x over x cubed is 2 over x squared. And I haven't been writing it, I've been sloppy here, but I should be writing the limit as x goes to infinity. You should write that every time. Do as I say, not as I do. Same thing here, limit as x goes to infinity. And now let's let x go to infinity, right? Let's think about what each of these terms does when x becomes infinitely large. By the same logic here, and this is one of the limit laws that you're expected to always kind of remember. 1 over x is going to go to 0. 1 over x squared is going to go to 0. 2 over x squared is the same as 1 over x squared, right? Whether the integer is 1 or 2, it's still over an infinitely large number, so that's going to go to 0. And what we find is that this is going to become 0 over 1, which is 0. So either way you do it, you get 0. And one additional method that I want to mention for folks that have already been exposed to derivatives is L'Hopital's rule, which says that you can take the derivative. If you have a situation where if we were to just make a direct substitution and let x go to infinity in the numerator and denominator, we would find that the limit was infinity over infinity. And that's called an indeterminate form whenever you get infinity over infinity. Same thing if you were to get 0 over 0. That's not enough to say that the limit is 0, right? So when you get these indeterminate forms, what you can do is take the derivative of the numerator and the denominator, and the limit of that function is the same as the limit of the original function. And this isn't terribly hard to do. So let's take the derivative of the numerator and the denominator. Well, that would just become limit as x goes to infinity of 2x plus 1 in the numerator over 3x squared plus 2. And now if we let x go to infinity, unfortunately we still get infinity in the numerator and infinity in the denominator. So this didn't really seem to help. But with L'Hopital's rule, if we get the indeterminate form again, right? If we get infinity over infinity again, we can repeat the process. We can differentiate this once more. So let's keep going. Limit as x approaches infinity. Now it would become 2 over 6x. And I suppose you could simplify that, right? Make that 1 over 3. But regardless, now you have 1 over an infinitely large number. And what does that become? 0. So regardless of which method you use, you always find out that the limit equals 0. So it all connects and it all makes sense. If you don't know derivatives yet, don't worry. That's typically covered, depending on the order in which your course does limits and derivatives. You might not necessarily learn this rule until later. If it's a high school course, you may not actually cover L'Hopital's at all. But hopefully that made some sense. And if not, you can use one of the other two methods.